Okay, neat. We're going to start notes 5-9 today. This is another type of identity, but we generally just use this when we are solving equations. Your warm-up, number one, you definitely should have been able to knock out of the park without me. It should be 3 plus radical 3, and then 6 minus radical 2. And then when we're talking about dividing like some ugly radicals like this without a calculator, the idea is you want to multiply it by the conjugate of the denominator. Conjugates get rid of kind of the ugly i's or the ugly radicals. So even though I start off with a negative 3, we're going to keep that negative 3. With conjugates, the only thing that we make the opposite is the second term. So negative 3 minus radical 3. Technically, these are turning into FOIL problems. So if you wanted to, you could have thrown a set of parentheses around. You definitely don't have to, as long as you kind of do the double distributive property for both of them. Simplify everything down, your answer should be negative 1. Prior to today, we have only been able to memorize and find exact values of sine, cosine, and tangent for the 16 angles in our unit circle. Today, we're going to be able to use these sum and difference identities to kind of add and subtract known angles from our unit circle to find things like sine of 15 degrees or like tangent of 11 pi over 12. You could do 11 pi over 6, but not 11 pi over 12. These are our new identities. These are ones that you're going to have to memorize, but after using them, usually most people are okay with them. Sine's the easiest one. So what this is saying is x is an angle and y is an angle. So x is equal to an angle, we could say like 30 degrees, and y is equal to an angle, and we could say something like 45 degrees. So when we're plugging and chugging, kind of see what those mean. I would like you to write down these three different identities on your trig identity reference sheet. I think it's green this year. So this would be like 30 degrees and 45 degrees. If we're adding them, it stays adding. If we're subtracting them, it stays subtracting. So this would be, we'll say plus, this would represent sine of 75 degrees, and you literally just throw these bad boys in. Your x is 30 and y is 45. What you'll notice on this one is it stays 30 degrees the first, and then it flips your trig. So this is sine, cosine, cosine, sine. Be careful with your x's and your y's. Now, cosine is where things get a little tricky, and it's green so that you notice that it's the opposite. So if I'm adding, so we'll keep this as 30 plus 45. When I use my identity, it needs to be subtract. So this would be cosine of 30, cosine of 45, subtract sine of 30, sine of 45. Okay, so when we're adding, so this would be something like cosine of 75 degrees, we use subtraction in the actual identity to simplify it. Tangent's the same way for the denominator. So we'll keep this as tangent, and we'll say of 75 degrees. So 30 plus 45, and the numerator, it's going to be tangent of 30 plus tangent of 45. And the denominator would be 1 subtract tangent of 30, tangent of 45. So sine stays the same. Cosine and tangent, there are parts in each of them where it becomes the opposite. I would also suggest when we're working through these, it's always so much easier to work in degrees. So if you can work in degrees, please do so. First one we're going to do is actually cosine of 75 degrees. So we're going to be focusing on this identity right here. There are lots of different ways to get to 75. I just showed you 30 plus 45 degrees is one way to get to 75. When we use these different trig identities, we're limited to angles that we know from the unit circle for these to work. So I can't come in here and say, okay, well, 75 degrees, that's 60 plus 15. I know something about 60 off my unit circle. I don't know anything about 15. So 60 plus 15 would not be a good option. I have my calculator out, so if you want to kind of fiddle around, we could do 135 degrees minus 60 degrees, and that would take me to 75 degrees. That's another way to get there. We know both of those values. Let's see, what else could we do? And one last one we'll throw up there. We could do 225 degrees minus 150 degrees. So all these are kind of different ways that we could go. Use the angles off our unit circle to get to cosine. What I would like to do is we're going to actually do this one. We're going to do cosine of 135 degrees minus 60 degrees. So 135 degrees minus 60 degrees. When we use our identities, this would be my x, this would be my y. It's going to be cosine of 135 degrees times cosine of 60 degrees. And I'm really just looking right up here. This is subtract, so that means we're going to make this into plus. Sine of 135 degrees, sine of 60 degrees. Now once we have this is why I want to do this one. It gets a little bit tricky. I want to go ahead and draw my unit circle. 135 degrees is hanging out over here, and 60 degrees would be hanging out right here. Now for 60, this is my all quadrant, so everything is positive. But for my 135, this is my S quadrant, so only sine is going to be positive. So I'm going to be careful when I'm over here doing cosine of 135 degrees. Now cosine of 135 degrees, it's a 45-degree reference angle, so it should be radical 2 over 2, but we need to do that as negative because of the quadrant that it's in. Cosine of 60 is a 60-degree reference angle. Multiply that by, it should be positive 1/2. Add that to sine of 135 degrees, radical 2 over 2, it is positive. Sine is the height. Height is positive in the second quadrant. And then sine of 60, sine again is the height, so it's going to be radical 3 over 2. From here, it looks like we're going to have negative 2 over 4 plus radical 6 over 4. And probably the nicest way that we could write this would be something like that. So the exact value of cosine of 75 degrees is that bad boy right there. We'll check it in our calculators. Okay, you just want to make sure that you're in degree mode on your calculator. Throw in cosine of 75, type in the expression that we found. You could have even done this expression as well. You find they're both equivalent. Let's go ahead and take care of a tangent version. So we're focusing on the one that has green next to it. Convert to degrees. Easiest thing that you can possibly do is basically you're going to do 7/12 times 180. Let's do 7 divided by 12 times 180. Grand total. Grand total of 105 degrees. So even though in the last one I made you do kind of a harder version, you definitely want to try to stay in the first quadrant if you possibly can. So 105 degrees, let's see a few different ways that we could get there. We could do 45 plus 60. You could also do 135 degrees minus 30. You could do 225 degrees minus 120. Now, the easiest ones that the way that's going to stay the easiest for you is going to be to stay in the first quadrant. So we'll go ahead and we'll do the easy version this time. So this is going to be tangent of 45 degrees plus 60 degrees. That's going to be equal to, this is my x, this is my y, tangent of 45. And then with the top of tangent in the numerator, it's going to stay the same, plus tangent of 60. All over 1. Now this is going to be the opposite, so 1 subtract tangent of 45 degrees times tangent of 60 degrees. Another thing I would caution you about using with tangent is tangent of 60 is nice, it's just radical 3. Tangent of 30 is not nice, it's radical 3 over 3. I thought we wrote that down someplace. Apparently, that was the last section of notes. So I would caution you against using 30 degrees when dealing with tangent. You want to use 45s and 60s with tangent, with your reference angle. So even this one would have been an okay choice because the reference angle for 120 is 60 degrees. We're going to stay in the first quadrant, so everything's going to be positive when we do our trig stuff. So tangent of 45 is 1, tangent of 60 is radical 3. And then denominator 1, subtract, tangent of 45 is 1, tangent of 60 is still radical 3. So this is going to be 1 plus radical 3 over 1 minus radical 3. That is not considered simplified. You need to go in and actually do the conjugate business that we did in our warm-up. So 1 plus radical 3, 1 plus radical 3. Numerator, this is going to change into 3. 1 plus 3 is 4, so 4 plus 2, radical 3 over, these guys cancel. This would be 3 as well. 1 subtract 3 would give me negative 2. So negative 2 minus radical 3. You would want to go ahead and check your answer. So tangent of 105 degrees is this. Negative 2 subtract radical 3 is this. So they do match. This would be our nice simplified answer. Let's go ahead and take care of a negative version. So a negative 15 degrees. I think the easiest one for us to find, the one that's popping in my mind, would be 30 degrees minus 45 degrees. So sine of 30 degrees minus 45 degrees. We're going to focus on this identity here, and with sine it's going to stay the same. So this is my x, this is my y. So sine of 30 degrees times times cosine of 45 degrees. Subtract cosine of 30 degrees, sine of 45 degrees. We're in the first quadrant for everything, which is what you want to prefer. 30 degrees is hanging out right here. So 1/2 times radical 2 over 2. Subtract cosine of 30 is radical 3 over 2. Sine of 45, radical 2 over 2. So radical 2 over 4, subtract radical 6 over 4. Write it as one fraction. Oops. Radical 2 minus radical 6 over 4. Nothing too crazy. And the last one, 11 pi over 12. Convert that into degrees very quickly. Okay, so that would be cosine of 165 degrees. I think the easiest one for us to do would be 135 plus 30. Be careful because 135 is in that second quadrant, and it's going to be a little bit trickier because only sine is positive in that quadrant. So cosine of 135 degrees plus 30 degrees, we're going to focus on this identity. That's going to turn into cosine of 135 times cosine of 30. Subtract sine of 135 times sine of 130. Remember, these have to be opposite with cosine. All students, so this is going to be, all of them are positive in the first quadrant, just sine in the second. Cosine of 135, 45 degree reference angle, negative radical 2 over 2. Cosine of 30, cosine's your base, so radical 3 over 2. Keep the subtract. Sine of 135 is positive radical 2 over 2. Sine of 30 is 1/2. Negative radical 6 minus over 4 minus radical 2 over 4. Simplifies down into negative radical 6 minus radical 2 all over 4.